welcome to Vodcast 14.3. In this Vodcast, I will overview mid-latitude cyclones. Mid-latitude cyclones are the primary weather producers in the middle latitudes. The idealized weather for mid-latitude cyclones is that they'll move eastward across the United States. And as a result of that movement, the first signs of their approach will be in the western sky. A mid-latitude cyclone will usually require 2 to 4 days to pass over a region, and the largest weather contrast with mid-latitude cyclones will occur in the spring months, because the continental polar air masses coming from Canada are really cold, and that contrasts very well with the warm, moist maritime tropical air masses coming from the Gulf of Mexico. In fact, that's one of the reasons tornado season occurs in the spring months. Specifically, in the spring, we're talking about the clashing of very cold air and warm, moist air. The weather will change with the passage of a mid-latitude cyclone. And as shown in the middle image, the weather you experience depends on your location with respect to the cyclonic center. Now, before we look at the three-dimensional view from points A to B, I should stress that mid-latitude cyclones are quite easy to understand. These are cyclones that occur in the mid-latitude regions. And keep in mind with cyclones, we have convergence of winds at the surface. The airflow is in a counterclockwise manner around the cyclonic center. We'll see ascending air, adiabatic cooling, and a lot of cloud formation, and that cyclonic center will be associated with divergence aloft. At this point, I'd like you to take a look at the map view and notice the line segment connecting point A and point B. Point A occurs in Iowa, and point B is all the way on the eastern seaboard. Let's take a look at the three-dimensional view that shows us what's going on with the mid-latitude cyclone. At point A, the cold front has already passed you, and you may have had severe weather just a little while ago. The cold front is now advancing into Illinois, and it kind of bows its way backward through Texas and out west. What's really important to note here is that we have warm, moist air coming off the Gulf of Mexico, and we see a maritime tropical air mass influencing weather in the southeast United States and all the way up to the Great Lakes. But coming from the north is a cold continental polar air mass. And the line separating that maritime tropical air from that continental polar air is that cold front. And it's along that line that you'll see the most powerful thunderstorms associated with this mid-latitude cyclone. In fact, for us in Illinois, we would probably have to start preparing for some severe weather. Now, that continental polar air is going to keep pushing its way south, and that maritime tropical air is going to keep pushing its way to the north. In the area between the warm front and the cold front associated with this mid-latitude cyclone, you'd likely be seeing warm, humid conditions and ample sunshine. But as we work our way out to point B, which is near the Atlantic Ocean, there's an approaching warm front, and as that warm front nears, they could see some nimbostratus cloud formation and some moderate precipitation. Point B is being influenced by a maritime polar air mass, and that air mass is associated with humid, cool conditions. And although this image isn't a GIF, we would expect to see that warm front continue to work its way in the northern direction, and that bowed cold front, which kind of looks like a comet tail, will probably continue to advance in the southeast direction. This slide kind of builds on some of the things I just talked about on the previous slide. With that advancing warm front, the clouds will become lower and thicker, and you may see some light precipitation. After the passage of the warm front, the winds will become more southerly, and the temperatures will warm because warm air has overtaken the area. As the cold front approaches, you'll see a wall of dark clouds. You can see heavy precipitation, hail, and even the occasional tornado. But after the passage of the cold front, the winds will become more northerly. If you look at this image and notice the winds associated with places to the left of the cold front, you see that a lot of them are coming out of the west or the northwest. You'll also notice the skies will clear after the passage of that cold front. So you may get some severe weather, but then the conditions will clear out pretty quickly. And of course, after the cold front passes, you should expect the temperatures to drop because you are now immersed in cold air. Another important note to make on this particular slide is depending on the context, the word cyclone may refer to a tornado, a hurricane, or a large-scale atmospheric system in the mid-latitudes. I think it's important that we know that mid-latitude cyclones are enormous cyclonic storms. The final concept I'd like to overview in this vodcast is a concept that I've overviewed in a previous vodcast, and that is the dynamic interaction of what's happening with highs and lows at the surface and what's happening aloft. With cyclones, we see surface convergence, counterclockwise airflow, rising air, and then divergence aloft. But for that cyclone to be maintained or strengthened, we must have divergence aloft. And without divergence aloft, these mid-latitude cyclones would fizzle out pretty quickly. I'm aware that we spend a lot more time talking about cyclones than anticyclones, but anticyclones are essential for the maintenance or strengthening of a cyclonic center. With anticyclones, we see convergence aloft, we see descending air, and we see surface divergence. So hopefully you can see the well-connected cycle both at the surface and aloft for highs and lows. Okay, that concludes this video podcast. In our upcoming Vodcast, we will talk about severe weather, specifically thunderstorms, tornadoes, and hurricanes.